Hello guys, my today's topic is more questions on factorization using special algebraic identities. I hope all the identities are in your mind. There are only 3 identities, and if you have watched my previous videos, identities must be fresh in your mind, and side by side I'm also giving you concerned ID in rough column or before or after the question for your convenience. Now come to question number 1. Factorize completely using identities. This instruction is for all the questions given below. My first question is 36w square minus 4we plus 1 over 9e square. This is a quadratic expression and we are going to factorize it. Factorization is reverse process of expansion. When we are going towards factorization, expansion is giving to us. This is an expansion. This term, this whole expression is an expansion. When we move towards factorization, we are given with expansions, and when we move towards expansions, we are given with factors form. I hope it's clear. Now look at this. In this question, there are only 3 steps. First term is 36w square. W has square on it, and 36 square, we will find out what number gives us 36. I think 6 square. When we multiply 6 by 6, we get 36. So 6 square gives us 36 when we multiply 6 with 6, because 6 square means 6 multiplied by 6. It means we can write down 36 as 6 square. Where is the square of 6? Here at the bracket. Where is the square of w? Here at the bracket. Alright. When we have a square power over the bracket, all the terms inside the bracket has that power. They are with squares. It means this square is not only of w, this is of 6 as well. Now come to the last term first. Don't come to the middle first. Come to the last term first. There is a convenient factor for you to write down last term and first term. Which last and first? Containing squares. Terms containing squares, write down first in their other forms. Now 1 by 9 can be written 1 by 9. E square is also in the form of square. So 1 by 9 can be written as 1 over 3 square, because square of 1 is 1 and square of 3 is 9. It means 1 by 9 can be written in the form of square as 1 by 3 square. Now square is at the brackets, and this square is the square of all the terms inside the brackets. Now we have enclosed 1 over 9e square inside the brackets and wrote square at the top. Now this square and this square terms under the squares. These terms under the square will help us to make or to break the central term into 2ab. Why I am going towards 2ab? Look at this ID. There is a negative sign with the middle term, and middle term has no square. So when there is a term, when there is an expression, first of all I want to tell you, when there is an expression with 2 squares and there is a term in the middle with some negative or positive sign, we revise all the three identities in our mind. When we have negative sign with the middle term, which is without squares, then we will move towards identity 2. Look at this. This is ID2. ID2's reverse form is given to you, right? A square minus 2ab plus b square is equal to a minus b whole square is ID2, and it is written in its reverse form. Now we are given with this expression. Look up, two squares and one internal term, middle term is given to us in this expression. It means this portion of the ID resemble with this question, right? With this expression. So it is given. That is why I have written over here given. This portion is given. When a portion of an ID is given to us, we will move towards the other portion. Whether that is the right hand side or left hand side, we don't have any concern with that. We will move towards the other side of the ID. Now the other side is a minus b whole square. So we will move towards this, and to get this we will convert the given expression in the form of a square minus 2ab plus b square. In this question, now look at this. I have underlined first term. In this question, A is replaced by 6W. Look at A in the rough column. A is equal to 6W and B is equal to the last term 1 by 3E. Here are in this expression, when we have written it in the form of 2 a, b and a square and b square, when we wrote it like this, here our a is 6w, our b is 1 by 3e, and our 2ab with negative sign is 2 multiplied by a because a is 6w and multiplied by b because b is 1 over 3e. This way we will complete the central term, or we will convert, or we will write the central term in the form of 2ab. Now this whole expression is ready to be factorized with the help of an ID. Which ID? ID2. What is the other side of this ID? A minus b whole square. Can we write down when we have a square minus 2ab plus b square, then we can enclose this whole expression in the form of a minus b whole square. What is a over here? 6w. What is b over here? 1 by 3e written. What is the sign with the middle term? Minus. So we pick up the sign of 2ab. Remember, we always write down the sign of 2ab in the middle in the center of a and b. In between a and b, we write down which sign? Which comes with 2ab. So this is how to complete a square, and this is how to write down factor in collective form. We have written two factors which are 6w minus 1 by 3e in collective form. It means we have factorized this given expression like this with the help of ID 2. Remember, with the help of ID 2, we wrote the given expression in the form of factors, which is the last step of the question. We always do this. We write down the given expression in the appropriate form, then we pick up just a and b and sign of 2ab, because here our a is 6w and our b is 1 by 3e. That is why I am calling it 2ab. We pick up this sign, we pick up this a, we pick up this b and write it down inside a square with this encircled sign of middle term. I hope it's clear. Now come to question number 2. Question number 2 has two squares. These squares are given to you. These are in front of you. W 4W square minus 25K square. Now we don't have three terms. This is expanded form. We are given with expanded form and we will move towards the factor form of this question with the help of concerned appropriate identity. Now can I write down 4W square as 2W square as I have explained before? Look up, 4 is square of 2. When we multiply 2 with 2, we get 4. It means 4 can be written as 2 square. And W is already in the form of square. So both the numbers can be write down. Both the numbers, this alphabet and this term actually, this term 4W square could be written as 2W square at the bracket. Now we have enclosed it inside an individual bracket because this square is power of every term inside the bracket. Now 2 square means 4 and W square is W square. We can get back this term. You can check it. Come to the next term, minus 25 we can get with the help of 5 square. 25 is a square of 5. When we multiply 5 with 5, we get 5 5s are 25. It means 25 can be written as 5 square and k is already in the form of square. So can we write down the square of both the terms over here once and enclose them inside a bracket? It means it is the same thing as we are given with, only its form is converted to apply an ID. Okay, we always convert given form, expanded form towards that ID which is concerned, and then we can use that ID when we have here a perfect one side of that concerned ID. Now look at this ID3. ID3 was in my previous videos. This was a square minus b square is equal to a plus b into a minus b. A square is a square, b square is a square, arrows are showing square form. This was called difference of two squares, right? And it is equal to two factors, a plus b and a minus b. Now we are given this side. We are given with two squares with minus sign, means we are given with difference of two squares here. This square and minus sign is helping us to take this step. Okay, so 4W square can be written as 2W whole square minus 25K square can be written as 5K whole square. Now the alphabet A of ID3 is replaced by 2W and alphabet B is replaced by 5K. This is our A now. 2W is our A and 5K is our B. It means we have converted the given expression into A square minus B square, which is the left side of ID3 in reverse form. And that is equal to what? Simple as that. Now we can write down A plus B and A minus B. This would be the answer. What is our A over here? 2W. What is B? 5K with plus sign because formula is saying this. This first factor. A plus B means 2W plus 5K because our A is 2W and B is 5K. Into 2W minus 5K means A minus B. Now we got A plus B and A minus B with the help of ID 3. This way we use identities to solve questions according to the given instruction using special algebraic identities. So we will factorize completely using identities. That is why we are using these identities, because instructions are saying this. Now question number 2 is solved, and this was square of 2 difference of two squares, and ID3 is used over here to get this factor form. These are two factors now. Brackets are attached with each other without any sign. It means both the terms are written in the form of factors. Now come to question number 3, because same ID is being used in this question. We are using it. The same ID we are using in this question as well. That is why I have written this ID with these two questions once only over here. Now question number 3, look up. Many students do this blunder. They look at 8 and they write it down as 4 square. No, because 4 square means 16, not 8. 8 is not square of any number. So we will convert it into such a number which would be a square of any number, right? So how we will convert it? We will take the number which is common in both the terms. What is common in 8 and 18? I think 2. When 2 is common, divide 8w square by 2, you will get 4w square. And 18k square divided by 2, you will get 9k square. 2 9s 18. So when we take 2 common, we will divide both the numbers by 2 alphabets. W square and k square will come as it is. And these two numbers after divisions will give us 4 and 9. 4 and 9 both are perfect square of a number, right? Now we can write down these 4 and 9 as a square. 4 is square of 2 and 9 is square of 3. W square and k square is already in the form of square. Now 2 will come as a factor as it is. It is also the factor of these two terms because we are factorizing. That is why 2 is also a factor. It will come with every step as a factor. Now 2 will come down as it is. Bracket, big bracket start. You will solve the whole question inside this boundary, inside this big bracket, right? 4w square can be written as 2w whole square, as I have explained before in question number 2. Minus 9k square can be written as 3k square. When we will apply, now just to check whether we are right or wrong, we will apply this square on both the numbers in our mind. 2 square means 4 and w square means w square. It means we are able to get 4w square and 9k square from this back. It means our conversion is correct. 2w square minus 3k square is another form of 4w square minus 9k square. So it's a correct form. You should always check when you convert some term or number into another form. You should check it whether we are getting it back or not. If you are not getting it back, it means your conversion is wrong. Okay. Now come to the next step, 2 as it is. We have got now again a square minus b square. What is a over here? 2w and b 3k. Now our a is 2w and b is 3k. We will write down a plus b and a minus b like this. 2w plus 3k, 2w minus 3k. This is a plus b and a minus b. Now we will omit this big bracket at the end because question is completely factorized, which is inside the big bracket. When the expression inside the big bracket is completely factorized, then we will remove this big bracket only, not the small brackets. And here we have used ID 3 again. 2 will come as it is and these factors will come as it is. These are 3 factors of the given term 8w square minus 18k square. This is the solution of question number 3. That's all about this video. I hope everything is clear. Guys, if my videos are beneficial for you, do like and subscribe so that you may get notification of my upcoming videos. Thank you.